Hello YouTube, RJ. Hey, this is a video I've put off making because it's a follow-up to a video that I made a while ago called Antenna Tuners Do Not Tune Your Antenna. And I made a couple statements in there that has turned out not to be correct, and I wanted to make sure and correct those. I don't want to be unfactual in my statement, so I'm going to make sure that I correct those two statements before we get too far in. And then I'm going to get into really looking into the facts around antenna tuners and tuning antennas. I'm going to ask three experts their opinion, just cold, hey, what do you think of this? Do antenna tuners tune antennas? We'll get their input. And then we'll take a look at some of the different arguments about antennas being tuned by antenna tuners, and we'll actually dissect them, get right down deep into it, look at it. And then the end will be, I'm going to lay out exactly what's going on with an antenna tuner and why an antenna tuner does what it does, what causes it, what effects we see from it, and give you the complete picture of tuning an antenna with an antenna tuner. So this is one that might be a little long, but you're going to want to hang in there and make sure you watch it through the end because there's going to be some interesting things that come out on it. So first, I've got to get into the two statements I made that I want to correct. One was, I made the comment in the previous video that this might be a little controversial. That was terribly wrong. It was quite controversial. I had a number of people very upset with that video. They absolutely did not like my opinion on antenna tuners. And so that turned out to be wrong. The other thing that I was wrong on was part of the video tagline and such was what most people get wrong about this. And surprisingly, the truth is most people didn't get it wrong. Most people didn't think the antenna tuner was tuning the antenna, but was matching your radio to the antenna. It showed in the comments, it showed in the emails, it showed in a whole bunch of ways. I saw that the vast majority actually get it. They understand. And it was only a minority that believed the antenna was being tuned by the antenna tuner. So I thought I'd give this a little time to calm down a little bit and where we could rationally talk about it. I had some very, very vile comments made to me, everything from I'm ignorant to, basically, I don't know anything about electronics. Because of that, I thought, okay, give it some time. Let's get back into it. And let's not just make the statement that the antenna is not being tuned by the antenna tuner. Let me show you why it's not. Let me show you that that's widely understood. But the first thing we need to do before we do anything is because one of the little ways people play games with this is you have an antenna. And everybody knows what the antenna in your ham system is. And you know what your feed line is, and you know what an antenna tuner is, and you know what a radio is. But once you start this argument with people arguing that you are tuning the antenna, magically as you're arguing, they'll stop saying, you're making the antenna resonant. You're moving the resonance of the antenna. That'll go away in the argument. And what will come out is this mystical beast called the antenna system. We start out with an antenna feed line, an antenna tuner, and a radio. And somehow or another, we end up with an antenna system in the middle of the argument. And that's because it's really more of a how you're trying to group things together and how you're trying to massage it to what you want to be able to argue your point. So we're going to do a little vocabulary game here. We're going to define things. An antenna is an antenna. It's from the feed point, it's the wire, it's the vertical, it's the antenna. Everything from the feed point to the end of the antenna is the antenna. That's it. The antenna is the antenna. So when I say antenna, I mean the antenna. So when I say the antenna tuner, I'm talking about the antenna tuner box. And when I say it does not tune the antenna, I mean it does not tune the antenna. That's what I'm saying. I'm not going to play games with these arguments about how, wait, that's part of the antenna. No, it's not. Your feed line, your antenna tuner is not part of your antenna. I can group all of it together and say it's a ham radio system if I wanted to, but that's not practical when you're discussing this stuff. So we're going to stay with the antenna is the antenna, the tuner is the tuner, the feed line is the feed line. So that's important to understand. I want everybody to be on the same page as we go into this. So we're going to get into, does that antenna tuner actually tune your antenna? The other definition we need is, what's tune mean? What is a tuned antenna? Well, a tuned antenna is an antenna that the length, the height, the geometry, everything to do with that antenna, because we all know when it comes to antenna, everything affects everything. So every physical thing to do with that antenna affects its tune. It affects at what frequency it will be resonant. So we cut our wire of our antenna until we bring it into resonance and we say we've tuned the antenna. That means that antenna needs nothing done to it. It will be resonant at that frequency. So let's jump over the computer and first get a couple other opinions of whether antenna tuners tune antennas. So I'll see you over on the computer. This should be pretty interesting. Okay, here we are on the computer in ChatGPT, and we'll hit new chat. Make sure there's nothing left over from any other chat I've ever had. And we're going to ask the simple question: does an antenna tuner actually tune the antenna? Okay, we're going to use the same prompt. We're going to ask 3 different AIs. You're seeing this real time. This is the answer it's coming up with. You can repeat this to check me if you think I'm wrong. But here's what ChatGPT says. No, an antenna tuner does not actually tune the antenna itself. What an antenna tuner really does: matches the impedance of your antenna feed line and impedance of your radio, ensures the transmitter sees a friendly load. What it doesn't do: make your antenna resonant on the selected frequency, change the actual electrical length of the antenna, improve the antenna's efficiency. So we can see here, ChatGPT, no, it does not think that we are actually changing our antenna. It makes your radio happy, not necessarily your antenna, according to best rule of thumb here. Okay, here we are in Grok. We're going to do the same thing again. I'm going to ask it exactly the same thing. Oh, surprise? No, an antenna tuner, more accurately called an antenna matching unit or transmatch, does not actually tune the antenna itself in the sense of changing the physical or electrical length of the antenna to make it resonant. Here's what happens. So Grok also thinks that when people say tuning the antenna with a tuner is very common shorthand and ham radio, but technically imprecise. When they mean is I'm adjusting a matching network so my radio sees a good match. So short answer is no, antenna tuner does not tune the antenna. It tunes the impedance match between your radio and whatever the antenna feed line presents. The name antenna tuner is a historical misnomer that has stuck around for decades. So what do you know? Grok doesn't think so either. So hey, let's try one more. Okay, here we are. We jumped into Claude. So let's ask him the same thing. Surprise, surprise. It thinks the same thing, that it doesn't tune the antenna. So what we're going to close out with now is talk a little bit about what an antenna tuner does and why I and many people say it does not tune the antenna, where others, getting down in the mathematics and the semantics, claim that it does. So let's look at a basic transmitter here. We got a transmitter putting out 1 kilohertz, 50 ohm impedance, dumping into an antenna that's not resonant. It's 100 ohms and it's got some capacitance. If we simulate this and we take a look at the voltage waveform, we can see that this is my transmitter's transmitting out for 50 milliseconds, okay? This is it putting out the power, and you notice the moment it stops, what happens? Boom, nothing. If we look at how much power is getting dumped into the antenna, that's the blue line here. You'll see it's like 150 milliwatts. So, I'm sorry, microwatts when the transmitter is transmitting, and then of course nothing immediately when it shuts down. So keep that in mind, because what we're going to do is we're going to close this, and we're going to go look at. Now we've got an antenna tuner. Same setup, everything's the same antenna parameters, but we've thrown an antenna tuner in here. And what we've done is we want to, quote unquote, tune out the capacitance in the antenna. So we're going to use the inductor in the antenna tuner. We're going to add some inductance. And what's going to happen now is, by putting this in here, what we've really done is we've created a LC circuit. So inductive capacitive circuit. And this can be flipped. Maybe the antenna is inductive, so we use the capacitors in the tuner to zero it out. So we've created an LC network here. And so notice the antenna has not changed. Nothing about the antenna has changed. We're exactly the same. We've just put an antenna tuner in line. And so what's this going to do for us? In the previous demonstration, whenever the power would get down here and hit a wrong impedance, you would get a reflective wave returning, which would give you an elevated SWR that would come back to your transmitter here. You would see that on your SWR meter. And if it was high enough, your solid state transmitter is going to start backing the power down. So obviously we do not want that. It's not a matter of lost power and such, other than in this case, if everything is good, you're just going to reduce the power out of your transmitter. But with solid state electronics, they also don't do real well with the power being returned back. You can get voltages, and it's just not inside the realm. So they try to protect themselves. So with that in mind, we want to get rid of that. We do not want our transmitter seeing that reflected wave. What do? Well, we throw an antenna tuner in here. We create an LC circuit between the antenna is the capacitor in this case, and the antenna tuner is the inductor. And if we tune this inductor properly to where we get a conjugate match, which I know you hear the people arguing with me using that all the time. It's no magic. It's not, Harry Potter magic conjuntations or anything. It's just, all it is it means that the impedance here is equal and opposite to the impedance here. So if this is, say this was, just use an example of, say this was minus J30, this would be positive J30. So the two would cancel each other out, if you will. But what does that really mean? What really happens in this circuit? Well, with it tuned here, what's going to happen is I'm going to dump energy in. This tank circuit, being tuned to the same frequency as my transmitter, is going to happily accept that energy very easy. The transmitter is going to have no trouble putting power into this circuit. It looks like a perfect match. And this energy goes out to our antenna and radiates, but still not all of it, because we still have a mismatch from here to here. And so what happens is you get a reflected power back from here. The difference now is, instead of going back to our transmitter, it will reach this inductor. This inductor will absorb it and re-reflect it back. Now, if these parts were perfect and you had no loss in your feed line, this could go on forever. But it won't, because much of the power is going out the antenna out here and radiating. So it's only partial that reflects back. And when it goes back, most of that goes out. So this just continues on and on and on. You only lose what you lose in your transmission lines, in the resistive losses of your transmission line. So good transmission line makes a big difference. But I want you to understand something. You didn't tune this antenna. The antenna itself is not resonant. Let's run this now. Let's just take a look here, what the signal looks like. And note that we dump power in. We get up to 50 milliseconds where we're pretty well planed out. We're getting a little over 5 volts into it. And then what happens? The transmitter stops transmitting. What is all this? You'd say, well, it's ringing. Well, it's actually power transmitting back and forth, as I said, in this tank circuit. The tank circuit being one part the antenna and one part the antenna tuner. You're bouncing your energy back and forth in this tank circuit as normal. That means that since it's bouncing back in the tank circuit, your transmitter's not seeing that reflected wave, which is what we want. Okay, what happens if I detune my antenna tuner? Let's say that I change it to 50 microhenries. I know for a fact 100 and 253.3 microfarads is tuned. This is tuned to 1 kilohertz. So let's change that and let's see what the pattern looks like. Ooh, very different. Notice how ugly it is trying to put power into the antenna circuit, and notice that how quickly we dissipate it once we turn it off. And if I detune it even more, let's go to 20. You can see the difference. Now, without the antenna tuner, the moment the transmitter stops, it stops. This is what's going on. This is why you tune, and this is what you're tuning. You're tuning this LC circuit right here. You're not tuning the antenna. The antenna becomes part of a network here that I'll talk about in a second, and it's being tuned. We're going to tune it back to resonant, and when we do, notice that the transmitter has no problem. It's very clean, dumping power into it. Look how much longer and cleaner the continued reflections happen afterwards. So now let's jump over. Let's look at it from the point of view, Walter Maxwell, and reflections, and what everybody takes away from reading his books, And they believe, and he says, he does, there's a couple spots, only a couple, I think there's 2 times, and I went through and reread a bunch of his stuff, and I can only find like 2 times where he actually says the antenna's tuned. 99.9%, because let's face it, his book is just a repeat of the same thing over and over again about how all this works. What he's talking about is the mathematics of how a conjugate match deals with the reflections. That's what the book is about, okay? 99.9% of the time, he says the antenna tuner is tuning the antenna system. What's in this box? That includes the antenna tuner, the feed line, and the antenna put together. He's claiming your antenna tuner is tuning the antenna system. In 2 places, he says it tunes the antenna. Keep in mind, there's a difference between the antenna and the antenna system. When he talks about the antenna system, he's talking about this tank circuit. I don't disagree with that. There's not much you could find in his books I disagree with, or the things that I say that disagrees with what he says. The one thing is 2 places where he says you tune the antenna, I do not agree with that statement. I think that's misleading, and I'm going to tell you why. If you hang in there, I'm going to explain why I see that as not being tuning the antenna. So here's the deal. If you consider this an antenna system, yes, this tank circuit is being tuned by this antenna tuner. As you change this, as I just showed you, you're changing this antenna tuner. And if you don't get this tune resident, what happens is the transmitter still can't put power into the system effectively, and you still get reflections back to the transmitter. That's why we can stick an SWR meter right here and tune this, because we can watch the changes and see the SWR drop as we come close to resonant frequency. So that's what's going on. This is canceling out the capacity. I agree with that. The definition he likes to use is if there is no inductive or capacitive impedance here, it's zeroed out that you're at resonance. Well, under the definition, then you are canceling it. You could say this is resonant, but here's the problem. A tuned antenna to 95, 99% of hams means that the impedance is proper. It's a lot more than just mathematically canceling this out or electronically canceling this out. And why does that matter? I'm going to leave you with this thought. You decide whether you think the antenna is being tuned or not with this thought experiment. Let's say that we have a transmitter set on a certain frequency. Let's say it's tuned on 3.5 megahertz. And let's say that it is resonant on that and that everything's great. You get your SWR is very low. You radiate out of that antenna, which is I'm going to call it a dipole, just a standard dipole, half wavelength, standard dipole. Everything's working great. It's radiating well. And we know that we do a little test and we get on an antenna simulator, and then we go out in the field with a signal strength meter and a bunch of other equipment, and we do tests, and we find that this thing is radiating in a perfect dipole pattern. It's radiating the way you expect a dipole. There's no big lobes where it's much stronger off in certain directions and much weaker where there's knolls. And then we tune our transmitter to, I don't know, let's say we tune it to 7.1 megahertz. And now we're getting a lot of SWR. So what do? We hook up our antenna tuner and we tune the resonant circuit here, the LC circuit. We tune it to where we get low SWR, and we look and we realize we are getting effectively putting power into the antenna. That's working well. The antenna tuner is doing its job. My question is this: if that's equivalent, you've changed the antenna to where it's resonant. My question is this: will the radiation pattern of that antenna be the same as when I was on 3.5 megahertz? Will I go into the antenna simulation, or I go out with test equipment test? Would I find that it's the same, or would I find that it projects lobes off in certain directions, and there's knolls, there's areas I can't receive and transmit very well, and there's lobes where I can, and becomes these directional spikes and very unpredictable as far as not being able to evenly transmit out and receive in all directions? Which would I get? Do you believe that the antenna tuner is tuning the antenna? Because if you believe it is tuning electrically, making the antenna longer and shorter, doing away with all the negatives, then if you really believe that, then you believe the antenna tuner is tuning the antenna. If you're like me and know that that antenna will not radiate the same way, then you have to agree you're not truly tuning the antenna. You're creating a conjugate match. You're preventing the reflections from going to the radio. Therefore, you're matching the radio and the antenna together. And because of that, the antenna itself is not tuned to act as if it had been trimmed to be on the higher frequency. And so I'm going to close it out with that. I hope that some of this was entertaining and educational and made you think. So, hey, thanks for hanging out with me. I know this video is a little bit long. Hope you enjoyed it. And I hope to see you in the next video.